All right, let's talk about robots. I mean, we've all dreamt of it, right? Having a robot that could actually tidy up the living room or, put away the groceries. But that dream has always felt like it's stuck in the future. Well, today, we're going to dig into some really fascinating new research that explains exactly why that is and reveals a brilliant new way to train our future robot helpers way, way faster. So let's just start with the big question. Why can't we get a robot to tidy the house? Seriously, we have robots that can assemble cars with insane precision. We've sent them to Mars, but picking up a book from the floor, that's still a huge challenge. The answer is way more interesting than you might think, and it's really the core problem we're going to unpack. You see, the real bottleneck, the thing holding everything up, it isn't the hardware. It's not about building a better robot body. It's all about training the robot's brain. Think about it. Our homes are messy, chaotic, totally unpredictable places. Teaching an AI to navigate that world, to figure out how to pick up a delicate wine glass versus a heavy book, that is an absolutely massive challenge. And to really get why it's so hard, you have to know how researchers used to kind of cheat. In the early training simulators, they used something called a magical grasp. It was basically a video game cheat code. If the robot's hand got close enough to an object, the object would just, poof, teleport right into its gripper. Now, that's a neat shortcut for a simulation, but it's completely useless in the real world, where, physics is a thing. The real goal is to learn how to realistically grasp and move stuff without breaking it. So how do you teach a robot to do all this without breaking 1,000 coffee mugs and millions of dollars in equipment? Well, you send it to school, a virtual school. Simulators are basically these digital playgrounds where a robot's AI can practice a task over and over and over again, literally millions of times, learning from every single mistake without any real-world consequences. Okay, but to make sure these robots are actually learning the right lessons, researchers need a standardized test. In the AI world, this is called a benchmark. The analogy here is perfect. Think of it like a final exam for a robot's driving school. It lets all the different research teams test their AIs on the exact same challenges, so they can actually measure who's making real progress. And that brings us to the big breakthrough in this research paper. Scientists have developed a brand new super-powered benchmark. It's called ManiSkill-HAB, or just MS-HAB for short. It's designed specifically to crack this training problem for home assistant robots, and it does it with two incredible new features. Let's call them its superpowers. So, superpower number one is all about pure, raw speed. Learning anything takes practice, right? For an AI, practice means running through millions upon millions of simulations. So it's simple. The faster you can run those simulations, the faster the AI can learn. And let me tell you, this is a huge deal. MS-HAB is over 3 times faster than the best benchmark that came before it. Think about that. A training process that might have taken 3 weeks can now be done in just 1. This doesn't just save a bit of time, it's a game changer that speeds up the pace of innovation for the entire field. I mean, just look at the numbers here. They really tell the whole story. The old benchmark, Habitat 2.0, could handle about 1,400 training simulations or samples per second. That's pretty good. But by using some clever GPU acceleration, MSH just blows that away, hitting over 4,000 samples per second. This chart just makes it crystal clear what a massive leap in efficiency this is. The AI gets so much more practice in the same amount of time. But look, speed is only half of the puzzle. It's not just about practicing more, it's about practicing smarter. And that brings us to the second superpower of MSHB, an amazing automated system for quality control. It makes sure that the AIs are learning from only the absolute best examples of how to get a job done. So here's how it works. An AI tries a task, let's say picking up a box of crackers, thousands of times. The system is watching, and it records everything. Then it automatically labels every single attempt. Some are perfect, some are a little sloppy, and, well, a lot of them are just failed. The system then acts like a super strict editor, filtering out everything except for those perfect runs. It's like a sports coach creating a highlight reel of only flawless plays for the new athletes to study. Only the best of the best makes the cut. As the researchers themselves put it in the paper, when you combine this high-quality filtering with the incredible speed, you suddenly have a system that can generate massive amounts of perfect training data really quickly and efficiently. So you see, these two superpowers, speed and quality, they work together to create a much, much more powerful school for robots. Okay, so what does this all really mean for that dream of having a robot butler? Why should we care about a faster simulator and better data filtering? Well, because it tackles the biggest hurdles that have been holding the entire field of home robotics back. So let's just recap the key takeaways here. First, we get a simulator that's 3 times faster and, critically, uses realistic physics. No more of that magical grasp stuff. Second, it has an automated system to create these huge, high-quality data sets of perfect robot moves. This creates a new gold standard for training. And finally, and this part is so important, it's all open source. That means any researcher anywhere in the world can use these tools to build and test their own AIs. This is how you accelerate progress for an entire community. Look, the road to a real-life Rosie the Robot from the Jetsons is still a long one, but we have to be clear. Tools like ManiSkill-Hab aren't just a small incremental step. They represent a fundamental leap forward in our ability to train the artificial intelligence that will one day power these amazing machines. So it kind of leaves us with a fun final thought, right? As these virtual robot schools get better and the AI's training inside them gets smarter, what's the very first chore, the number one thing you would want your own personal robot to master? Definitely something to think about. Thanks so much for tuning in.